Okay, here we need to find the surface area of the square-based pyramid. So you can see this has a side length 8 here, and you can see these markings tell you that all of these are 8, which also the fact that it's a square-based pyramid as well tells you that all of these sides have to be the same length. So you've got the floor of this shape is a square with side length 8. You've also got 4 triangular walls, so these slanting lengths are all 5. It's not drawn brilliantly, it looks longer than the 8, but never mind. So 5, 5, that little one that you can just about see is 5, and this is 5 as well. You can tell by these markings here. That means equal length. So the surface is made up of the floor and the 4 triangular walls. So floor is easy. There's only one floor, and it's 8 centimeters by 8 centimeters square. So I'm just going to go ahead and say the area of that equals 8 squared, or 8 times 8 equals 64 cm squared. The walls will be a bit more tricky, so I'm going to draw one of these flat. So imagine if we unfold the thing, you're going to have 4 of these triangular walls. I'm going to try and draw one of these triangles. So it's isosceles. This is 5 centimeters, and this is 5 cm, and this whole thing is 8 centimeters. Right, so to find the area of a triangle at the moment, all we know is the area of a triangle is half base times height. So this 8 can be the base, no problem, but 5 is definitely not, that 5 is not perpendicular to the 8, so you can't call that a height. So we're going to have to work out a height. Now, if a triangle is equilateral or isosceles, you can drop a line like this, and it is a line of symmetry. It makes 90 degrees. Like that, and not only does it make 90 degrees, it will always make 90 degrees, but it also bisects these. So I'm going to draw 3 of these because we've already got a lot of equal lines going on. So if you have an isosceles or an equilateral triangle and you draw a perpendicular up from the base to the point, it makes 2 congruent right angled triangles. So if I just draw one of these, so think of this as at the left edge, so we'll call that left, L for left. If I just draw that here, so this 8 has been halved into 4, so this can be 4 cm. This slanting length is the 5 cm, and this we're going to call it h because it is the height of the triangle. So again, you're in Pythagoras Theorem. In any right angled triangle, a squared plus b squared equals c squared, where a and b are the short sides and c is the longest side opposite the right angle. C is the 5. So I'm going to write h squared plus 4 squared equals 5 squared. H squared plus 16 equals 25, so that means h squared, if we subtract 16 from both sides, equals 25 minus 16. 25 minus 16 is 9, so h squared equals 9. H equals the square root of 9, which is 3, so 3 squared is 9. H equals 3 cm. So now I can go back to here and I can write in that this is 3 cm, like that. Right, so now for the area of this triangle, of the 4 triangles that make up the walls, so total area made up by this, well it's 4 because there's 4 of them, times a half, times the base, well the base is 8 all the way along, times the height, which we now know is 3. So 4 times a half is the same as half of 4, is 2. 2 eighths is 16, 16 times 3 is 48. Now if you wanted to avoid doing 16 times 3, well, you could have done 8 times 3 is 24, or maybe a half times 8 is 4, and then 4 times 3, and so on. But either way, 2. But either way, this area represented by these 4 triangular walls is 48 cm squared. So that means that the total surface area is just 64 from, that was the floor, plus the 48 made from the 4 triangular walls. 60 plus 40 is 100, 4 plus 8 is 12, it must be 112 cm squared.